Hi and welcome back to another video. Today on the workbench we have got this Bock Compressor's MP10 motor protection system for refrigeration compressors. Basically what happens is in the windings of the compressor you've got a thermistor, a PTC thermistor there, and if the windings get too hot this unit goes and shuts down its relays to stop the power from going through and basically to stop your windings from overheating and melting down and melting the insulation and that. Which is good in case your secondary forms of protection fail. Now basically how this is wired, let's just move this down so you can see the terminals a bit better. Let me push you in a bit more. In this way, okay. So you got your live input and then it's got a live looping out, okay? Neutral input, neutral loops out. You see they just got little bridges across there. 43 and 44 weren't in use on this in this system. Then you've got your common in, your normally closed and your normally open contacts, which is basically what allows this compressor to get its control through here. As soon as this thing opens, then it shuts down the control for your compressor straight away. You've got two indicator lights there, and then you've got your PTC thermistor inputs. Okay, so basically how this thing was wired on the compressor that I went to go diagnose the other day. Your thermistor goes on those 2 points over there. Okay, that's in the windings of the motor. This actually fits in the pecker head or in the connection block on top of the motor, the compressor motor. Okay, then the live comes in here. Okay, and as you can see the live loops out this wire or out this terminal, goes into that terminal, which is a common of the relay, and then I believe they used that output there, M. Okay, so when this thing's happy, then it actually switches on. If it fails, then it drops down there and doesn't allow it to go through. Then they had neutrals looped over there. Okay, well, just one neutral coming in. And like I say, the output to the rest of the circuit went on M. But now what they had, they didn't have a cover on the one pressure switch, basically, and somebody dropped something metal on the one pressure switch and shorts it out. Now that runs after this unit. So when I got there, I found that there was no power to the pressure switches or the oil pressure switch, and then I traced it back to here and I saw I was getting nothing out of this relay, and I was also getting nothing on the brown. And then I actually looked and I saw, wait, they're supposed to be looping over here, but I was getting the 230 volts in on the first terminal. Now with that short that they had, they did actually blow a relay in that quite violently. So I know there was a pretty severe short. So I'm thinking in this unit here, they might have blown a trace out the back, which is causing it not to pass power on the live loop. If that's the case, then it should be a fairly easy fix. Just restore that link there, clean up any charred carbon, and then the thing should be ready to reinstall. So let's give it a shot. I have, just to keep them going, because this is one of their main refrigeration units, I did bypass this, so they've still got their basic overload protection and phase failure protection and all that. So, another thing I can see straight off the bat here, this relay's blown. You can actually see the relay. I don't know if you can see it in there, but it's actually you can actually see the contacts of the relay in there. So it also involves replacing the relay, I guess. So let's obviously want to keep the little lid of the relay. Now that's just the details of the unit itself, because we just need to make sure of the voltage and the pinout. Here we go. I'll pull the label off here. It's a JS12N-K. Okay, so if I'm looking at the data sheet for this relay, I don't know if you can see it clearly on the phone here. If we look, there, part number is JS-12. 12 is B, which is the coil voltage. Okay, so this is going to be a 12 volt DC coil. on the relay, which also we can judge because it's got a 5-volt regulator that's just for the logic. It's a 7805, okay? But then the transformer that we've got here is a 13 volts 1.2 VA, so normally they don't run the relay off the low voltage, so it's probably going to be a 12 volt relay, which obviously we just confirmed by looking at the relay data sheet. Okay, so now the PRs, the resistance. That French doesn't sound too good, but anyway. You can see there's some nice collection over there, and that chip over there, before we flip it over, that's a LM2903N. It's a dual low power, low offset voltage dual comparator. Okay, so it's just a comparator to compare when you basically it measures the resistance and sees when it's out of range, and then it will go and drop out the relay or switch on the relay depending. So now, I know you all want to see the back. Okay, we'll be back after this ad break. I'm kidding. Okay, let's take a look. Oh, shiny. I don't feel like shiny boards. Okay, so this is the live in and out. Over here, you can definitely see that there is some splatter there. Everything else, oh here we've also blown out here on the relay contacts. Yeah, so this was quite a dead short. I believe it was from the live to earth at 230 volts. Like I said, blew another relay in that control panel, tripped the 10 amp breaker, and obviously it's gone and destroyed that trace and destroyed the relay in here and destroyed these wires. So I guess we just have to start by cleaning up here and see about repairing the tracks, pull the relay, see if we can find another relay, because it is New Year's Eve, so if I don't have anything suitable, we'll have to wait a few days. But anyway, let's give it a shot. Take a bit of electrical cleaner, electronic cleaner, which is just basically an alcohol, isopropyl alcohol. This is not heavy carbon deposits on here that will be conducting. And then this is an easy to fix. We'll just put a bit of solder on that trace over there to patch that up. Put a little wire bridge across here. Depending on the relay that we get, we'll have to patch in some traces over there. So let me pull the relay out and I'll get right back to you. Okay, so unfortunately I don't have the right type of relay, and this is quite an urgent job. They don't really want to wait for it, so I've dead bugged another 12 volt relay on there. You can see there's the coil wires. And then I've got some nice thickish wires. The ones got a little tail sticking out. Some nice thickish wires that can handle the 10 amps needed. That just go through the board and onto those terminals. So now I just want to touch up this live here. And that bridge over there. And then I can also see that this neutral has arced away over there. So we'll also rebuild that quickly. My kingdom for a relay. I've got lots of relays. Whoa, where's the lens? Oh, there. Got lots of relays, but none of the right ones. So I'm just going to strip a bit of wire. To the live, to the link, because I don't trust that little piece of copper over there anyway. So I think we'll take it to the copper, but I want to take it all the way to that terminal there on the transformer, I believe it is. Oh, that's a, yeah, that's the MOLF, the surge protection. And already I'm hearing fireworks going off, and it's not even midnight yet. 22:09. Okay, sorry you missed that there. And then force it onto its original trajectory. Some more tinning. More stripping. Do a nice flow, make sure it's all tight on there. Remember, this isn't a lot of current going up there, that's just the control voltage. Your main power is going through that link, through here to the relay output. So the neutral as well, same story, it's just a control. 1.2 VA, isn't it? So 1.2 watts, very minimal power at maximum. It's just running that comparator and a relay. Now, solder's hot. Just in case you didn't know, solder is hot. It's strange that the neutral burnt out. It must have arced across or something. And just check the conductivity. Yeah, that doesn't look conductive anymore. So I think I'll just give it a quick power test, see if I'm getting 12 volts and all that. Can't do the full test because I don't have the PTC thermistors here. Just in the motor. Well, it's only one thermistor in this unit. Okay. So now I'm going to give it a hit of clear lacquer once I've tested it. Although in the motor's head you should not get any moisture in the pecker head. No, I think that's an American term for it. the terminal box on top of the compressor. Okay, so now just stripping some mains wire here. Live in. Put neutral in on that side there. Just as far away from the live. Okay. See what it does. If it goes bang, you can see on camera. Right. We got a H1 light. And I heard a relay click. So let me see. I'm getting power on that output. Nothing, almost nothing there. And then I'm getting the full 220 volts. Obviously this one's not bridged out. Maybe if we bridge this H1 out, this first probe, maybe then it will think it's okay and will give us power on the different terminal. Let's just see. Like I say, there was only one thermocouple, or thermistor, sorry, in the motor. So I don't know why this one's got a double, but anyway. Okay, so now I've bridged it out there. Now H1 and H2 are both off. And the relay clicks again. Oh, but you see now on the outside pin, we got power. Okay? So then we switch it off. Because I want to see next year. Take that off. So now, with that light on, we should have power on the inside pin. Yep, there we go. So basically it looks like it's working. The only thing is I could have the normally open, normally closed the wrong way around, depending on how this circuit works. But that's, I can always swap in field and then just change the labeling on here once I sort it out. Like I say, I've still got to do one or two other repairs there, replace that one control relay from the PLC that was blown and replace a breaker that was faulty in that, so this I can just add onto it as we go. But at least that is working, so they can have their blast freezer up and running by Tuesday morning, which is the end of the holidays. So I'm just going to give this a hitch with some clear lacquer, and then this one's good to go. Hope you enjoyed this one. If you liked it, give it a thumbs up, like and subscribe if you want, and enjoy your new year.